All right, good morning, everybody. What we're going to do is we're going to go through and solve this series circuit, because there's only one path to follow, for the total resistance, current, and voltage, as well as the voltage and current at each resistor. So to do that, first thing that we're going to do is we're going to look at the totals, right? So what is the total voltage? And I get the total voltage right here. So that's my total voltage, which is 12 volts. It's nice they gave it to me. What else can I do? Well, total resistance. My formula for total resistance is right here. And I'm going to solve for that by just simply, I guess I got the wrong pen there, by just simply adding together the resistor 1 plus the resistor 2 plus the resistor 3 value. So 220 ohms plus 470 ohms plus 1.2 kilo ohms, or 1200 ohms. All right, so keep that in mind. That's 1200 ohms, all right, because of the K. And when you add those together, you get 1890 ohms, which is our total resistance. But we're going to put that in significant digits, which is 1.9 kilo ohms. There's only two sig figs, two sig figs, two sig figs, two sig figs. So this should only have two. So we take the 8 and we go to the one next to it, which is 9, and that means we round up the 8 to a 9. So 1.9 kilo ohms. And finally, we can solve for the current total. And I had to do this in this way because there's no way to get the total current. Our formula, you'll recall, for total current of a series circuit is that the current in a series circuit is equal to the current at each individual circuit or individual resistor, but we don't know its current at each of them. So the other way we can do this is using Ohm's law, which says V equals IR. And if I solve it for I, I'll divide both sides by R. Those cancel out, and I is equal to V divided by R. So IT will be VT divided by RT, which in this case is 12 volts divided by, now I can't use the sig figs answer, right? I have to actually use the full answer, 1890 ohms. I can't use a rounded value. So hold on one sec. I need to go find my calculator. I don't know how I lost it. Uh-oh. Looks like it ran away from me. And that happens. What a bummer. I think I set it down in the back. And I guess that means it's gone. See if we got one that works. Oh, man. All right, I found a calculator. Sorry about that. And I want to do 12 divided by 1890. And I'm going to write that whole thing out. Oh, Lord. This calculator. All right, 2 divided by 315. How do I get the answer as a mode? Let me find another calculator here. Sorry about this. Oh, where is it? There we go. 12 divided by 1890 is 0.00634 206, and that is amps. And as sig figs, 2 of them, I go to the 4. 4 is less than 5, so that rounds down. So 6.3, and I'm actually going to move 1, 2, 3 spaces to the right, so I know that that's 6.3 milliamps. 6.3 milliamps. All right. Now the beautiful thing is, because that's total is 6.3 milliamps, I know that IR3 is 6.3 milliamps, IR2 is 6.3 milliamps, and IR1 is 6.3 milliamps, but only in a series circuit, right? 6.3 milliamps, 6.3 milliamps, and 6.3 milliamps. That wouldn't work in a parallel circuit. Finally, we got to solve for the voltages. And up here, I got 6.3 milliamps at each of these places. So I know the resistance and the current here. So to find the voltage at R1, all I've got to do is, I'm going to say VR1 is equal to the current at R1 times R1. But when I do this calculation, I cannot use 6.3. I have to use 0.0063 and write out that whole number, 49206 times 220. And let's see, we'll store this value as, how do I put in a value? Store it as, yeah, that didn't work. So answer times 220 is 1.3968 volts, and using 2 would be 1.4 volts. And then we repeat it, and 12 divided by 1890 times 470 is VR2, 0.006349206 times 470, which gave me 2.9841 volts. So we'll call that 3.0 volts. And finally, VR3 is 0.006349206 times 1200. Is 7.619 volts, or 7.6 volts. And then at the bottom here it says to verify Kirchhoff's that should say verify Kirchhoff's voltage law. And that would say that 12 volts is equal to 1.3968 plus 2.9841 plus 7.619. But I'm going to just use our values because I know they work, that we rounded. And it says 12 volts equals 12 volts. So Kirchhoff's law is complete. Thanks for watching. And as always, make sure you ring that bell, punch that like button, and holler at your boy in the comments below.